In Lab 15, we take a look at the construction of an IPv6 over IPv4 tunnel. Before we do that, though, we're going to identify different options to have IPv6 networks peacefully coexist with IPv4 networks. But again, our focus is going to be an IPv6 over IPv4 tunnel. We'll see the syntax to set up that type of tunnel, and we're going to go in and remove IPv6 configuration from a portion of the topology that we've already constructed, and then over that IPv4 only portion of the topology now, we're going to construct this tunnel and verify that we can indeed route IPv6 over that IPv4 portion of the network using that tunnel.
In our previous lab, lab number 14, we configured OSPF version 3 as our routing protocol for IP version 6 or IPv6 network traffic. And we had full reachability between all of our IPv6 networks. However, in the real world, as an enterprise is transitioning from an IPv4 network to an IPv6 network, there might be portions of the network at any given time that are still running IPv4. So what can an enterprise do during this transition? There are a few different options available. One option is the dual stack option. With the dual stack option, the router interfaces can be configured with both IPv4 addressing and IPv6 addressing, in addition to IPv4 and IPv6 routing protocols. Another approach is tunneling. We can create a virtual connection called a tunnel that's going to span the IPv4 region of the network. And this tunnel, it might span several routers. And once this tunnel is created by specifying the source and destination IPv4 addresses that make up this virtual connection, once that tunnel is created, that tunnel can be configured to encapsulate and transmit a variety of packet types. And one of those packet types that it could transmit is IPv6. We could transmit those IPv6 packets encapsulated over this tunnel. And when we talk about creating a tunnel, the tunnel could be created dynamically or manually. The dynamic approach is called a 6-to-4 tunnel, and that tunnel is going to be using a network prefix of 2002::/16. This 6-to-4 approach can be used to automatically interconnect IPv6 areas of the network, and each IPv6 area is assigned a 48-bit IPv6 prefix. And in addition to having the 2002 in the prefix, the remainder of the prefix, the remaining 32 bits specifically of the prefix, that can be taken automatically from the underlying IP version 4 address. That gives us 32 bits, and that's added on to the end of the 2002, which is 16 bits. That gives us our 48-bit IPv6 prefix. But what we're going to demonstrate in this lab is a manual tunnel. We're going to manually create a tunnel by specifying source and destination IPv4 addressing. And once the tunnel is up and functioning, each end of the tunnel, the virtual tunnel interfaces on the routers at each end of the tunnel specifically, those tunnel interfaces can be assigned IPv6 addressing, and optionally we could configure them to participate in an IPv6 routing process. That's what we're going to be doing in this lab. We're going to tell these tunnel interfaces to participate in the OSPF version 3 routing process already configured on that router. Let's remind ourselves now about the topology we're working with. In Lab 15, we're building on our configurations from Labs 13 and 14. Recall in Lab 13, we assigned IPv6 addressing to the routers in the topology. In Lab 14, we configured OSPF version 3 to be the routing protocol for our IPv6 traffic. And what we're going to be doing in Lab number 15 is going in and removing IPv6 configuration for that link between routers R1 and R2. Specifically, we will take away the B:/B:/B:/64 network. And these fast Ethernet 0/0 interfaces on R1 and R2, they will still have their IP version 4 addressing, but they are not going to be participating in OSPF version 3, and they are not going to have IPv6 addressing. Then what we will do is create a tunnel, a virtual connection between R1 and R2. For example, on router R1, this tunnel would be defined as having a source IP address of 192.168.1.1 and a destination IP address of 192.168.1.2. And we would have a mirror configuration of that on router R2. So we have an IP version 4 tunnel, and over this IP version 4 tunnel, we can send, as we mentioned, a variety of traffic types. And the traffic type we want to send over this tunnel is IPv6. So what we will do, we will go into these tunnel interfaces and we will add onto these tunnel interfaces IPv6 addressing. For example, we will say that the tunnel interface on router R2 has an IPv6 address of B:B:B:2/64, and we will also say that these interfaces are going to participate in the router's existing OSPF version 3 routing process. So even though the link between routers R1 and R2 is really an IP version 4 link, we're going to be encapsulating IP version 6 traffic inside of an IP version 4 tunnel packet. Let's take a look at the syntax that we're going to use to set this up. To create a virtual tunnel interface, in global configuration mode, we can say interface tunnel and give a locally unique interface ID. Then, once we're in interface configuration mode for that tunnel, we can specify the source and the destination IP addresses. And these IP addresses are IP version 4 IP addresses. And in our lab, these are adjacent routers. In other words, these IP version 4 addresses are on the same subnet, but it doesn't have to be that way. If we did have an IP version 4 routing protocol configured and we could reach a remote IP version 4 address maybe several router hops away, that would be perfectly acceptable. The tunnel does not have to exist just between two adjacent routers. The tunnel could span several routers making up the IP version 4 portion of the network. Also, in tunnel interface configuration mode, to configure this tunnel interface to act as a manual tunnel for IPv6 traffic, we're going to say tunnel mode IPv6 IP. And similar to how we added an IP version 6 address to an interface back in Lab 13, we're going to add an IP version 6 address to the tunnel interface in this lab. And similar to how we told an interface to participate in an OSPF routing process in Lab 14, we are going to tell the tunnel interfaces to participate in this OSPF routing process. Let's now go out to the routers and take a look at the configuration. In Lab 14, we configured OSPF version 3 to route between our IPv6 networks in our topology. However, in the real world, as an enterprise might be transitioning from IPv4 to IPv6, there might be pockets of the network that are still running IPv4, and to make these two environments of IPv4 and IPv6 coexist, one thing we could do is create a tunnel across the IPv4 area. To illustrate this concept, in this lab, let's remove the IPv6 addressing on this link between R1 and R2. Let's go into Fast Ethernet 0/0 on both R1 and R2 and say that this interface is not participating in OSPF version 3. This interface does not have an IP version 6 IP address. And then, once we've made this portion of the network not run IPv6, let's configure a tunnel across it, as diagrammed here. And in this example, this tunnel is only spanning the link between a couple of routers, but in the real world, realize this could be between any two routers, which might be separated by many other routers. But here we're just separating R1 and R2 with this OSPF version 4 portion of the network. Let's begin by removing our IPv6 configs on router R2. On router R2, let's go into global configuration mode, and we'll go into interface configuration mode for Fast Ethernet 0/0, and let's say no IPv6 OSPF process ID 1 area 1. We'll negate that command that we gave in the previous lab. Let's also remove its IP version 6 IP address. We simply say no IPv6 address, and we're done with our configuration on R2. Let's go over to router R1 and do the same thing. Let's go into interface Fast Ethernet 0/0, and we'll say no IPv6 OSPF 1 area 1, and also let's take away its IPv6 address. No IPv6 address. And now let's confirm that IPv6 is not being routed across this link between R1 and R2. To do that, let's issue on R1 a show IPv6 route command. And you'll notice from this output, R1, it no longer has any knowledge about the A:A:A:A/64 network off of router R2, and also the B:B:B:B/64 network is not visible either. Now, let's create a tunnel. Staying on R1, let's go back into global configuration mode and say interface tunnel, and we can give a locally significant identifier for this virtual interface. Let's just use a 1, interface tunnel 1. And for this tunnel, let's specify what is its source and destination IPv4 address. We're creating this on R1, so its source address is going to be 192.168.1.1, and the destination is going to be 192.168.1.2. So let's do this. Let's say tunnel source 192.168.1.1, the destination tunnel destination 192.168.1.2. Let's go over to router R2 and give a complementary configuration. Let's get into global configuration mode and let's create this virtual tunnel. We'll say interface tunnel 1. We'll specify a tunnel source address of 192.168.1.2, and the tunnel destination is going to be over on router R1 with an IP address of 192.168.1.1. And we're done with our tunnel creation on router R2. Let's do a show IP interface brief. And great news, it looks like tunnel 1 is up at layer 1 and layer 2. No IP addressing assigned yet to this tunnel. And by the way, this tunnel, it can now be used to transmit a variety of traffic types, such as IPX, AppleTalk, or in our case, IPv6. We next configure the tunnel with IPv6 addressing, and let's instruct the tunnel interfaces to participate in the OSPF version 3 routing process. Let's go back into interface configuration mode for our tunnel 1 interface and say IPv6 address B:B:B:B:2/64. Next, let's say IPv6 OSPF1 Area 1. And finally, to say that this tunnel is going to be transporting IPv6 traffic, we say the tunnel mode is IPv6 IP. Let's do the same thing on router R1. On router R1, let's go into interface configuration mode for the tunnel 1 interface and say IPv6 address B:B:B:1/64. Next, let's say that we want this interface to participate in router R1's OSPF version 3 routing process. We say IPv6 OSPF1 Area 1. And like we did on router R2, let's instruct this tunnel to transport IPv6 network traffic. We say tunnel mode IPv6 IP. And we're done with our configuration on router R1. This tunnel should now be acting as a conduit for IPv6 traffic to flow across this IPv4 network. And we can see on screen that we had a status change. It looks like we formed an OSPF adjacency. Let's verify, though, that IPv6 traffic is truly being propagated across this tunnel. Let's do a show IPv6 route. And it appears that routes are indeed being propagated across the tunnel. A few moments ago, we did not see the A:\A:\A:\A prefix, nor did we see the B:\B:\B:\B prefix. But just to verify that IPv6 traffic is truly flowing between R1 and R2, let's ping the fast Ethernet 0/1 interface over on router R2. Let's do a ping to A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\A:\ 2. And the successful ping confirms that we are routing IPv6 traffic across an IPv4 network segment. In this lab, we emulated a real-world scenario where an enterprise network might be migrating from an IP version 4 network to an IP version 6 network. Since this is probably not going to be a forklift upgrade, it's going to be done over a period of time. As an enterprise is doing that migration, there might be times when there are pockets or there are areas of the network that are just running IPv4. They've not yet moved to IPv6. And one way to help these two different environments coexist, as we illustrated in this lab, is to create a tunnel, a virtual connection that spans an IP version 4 portion of the network. And in this lab, that IPv4 portion of the network was fairly small. It was only between a couple of routers, but realize there could have been several routers across which that tunnel could transport that IPv6 traffic. And the way we set this up, we created a virtual interface, a virtual tunnel interface specifically, on the routers at each end of the tunnel. And on that tunnel, we configured source and destination IPv4 addressing. And once we were assured that the tunnel was up and functioning, we assigned IPv6 addressing to those tunnel interfaces. And we told those tunnel interfaces to participate in the OSPF version 3 routing process. And we told the tunnel mode to be IPv6 IP, which told it that it would be transporting IPv6 traffic. And that is going to conclude lab number 15. Thanks for joining us.